this video, we're going to talk about end behavior. So we're going to start by looking at the graph of f of x equals x to the third plus 5 on the Desmos graphing calculator. So here's my graph. The first question says what happens to the y values as the x values get bigger and bigger at the right end of the graph. So as my x values get larger and larger, I can see that my y values are also getting larger and larger. The graph is going to continue to increase as my x values increase. Y values increase as x increases. Or I could say the y values go to infinity. Question 4 says what happens to the y values as the x values get more and more negative at the left end of the graph. So as I go to the left and my x values get more and more negative, my y values also get more and more negative because the graph is continuing to go downward. So I will say that the y values get more negative as x gets more negative, or the y values go to negative infinity. Now we're going to look at a different graph. G of x equals 3x to the fourth plus x to the third plus 5. So I have that graphed right here. I can see that this graph looks different from the first one in that both sides are pointing upward. It looks similar to a parabola, but it has kind of this flat part here in the middle. So for this one, as the x values get bigger and bigger, the y values are also getting bigger and bigger. And as the x values get more and more negative, the y values are also getting bigger and bigger. So the y values increase for both. Or we could say that they go to infinity again. Question 7 says, based on your work above, how do you think the largest exponent in the function affects the behavior at the ends of the graph? So we see that the graph with the even degree, the degree of 4, increases on both sides. That's similar to a parabola, which has a degree of 2. So if the largest exponent is even, then both sides will go in the same direction. For the graph of x to the third, we had it going upward on one side and downward on the other side. So if the largest exponent is odd, then they will go in opposite directions. Question 8 says, what do you think would happen to the end behavior if f of x and g of x were reflected over the x-axis, and how do you know? So let's start with f of x. Here is our original function in red, and here is the function reflected over the x-axis. So we're reflecting it vertically over the x-axis, and that's going to make the green graph. Now what happens here is that the end behavior is opposite. So on the left side, as x becomes more and more negative, the y values are increasing. And as x becomes larger and larger in the positive direction, the y values are decreasing. If I look at my other graph, when it's reflected over the x-axis, now both sides are pointing downward. So as x increases, y is going to decrease, and as x decreases, y is going to decrease. So I will say it flips. And then question 9. What do you think would happen to the end behavior if f of x and g of x were shifted horizontally or vertically? How do you know? So let's go back to my graphs here. We'll start with the first one. So if I move the graph up or down, I can do that by adding or subtracting different numbers. Here, the graph moves up or down, and that moves where this middle point is located, but that does not change the direction of the two arms of the graph. We still have the one on the right pointing upward, and we still have the one on the left pointing downward. Same thing if I move it to side. So I can do that like this. By adding or subtracting a number to the x, but I'm moving, again, that middle point from side to side, but I am not changing the directions of the two arms. So the end behavior does not change. I still have increasing on the right side and decreasing on the left side. Same thing for the second graph. I can change the number here to move the graph up or down. I could also change the number in front of x. This one would be a little bit trickier because there's two x's. I would need to change both. But I could do that to move it side to side. But still, I'm still going to have it so that both sides are pointing upward. So the end behavior does not change. So when I go to the very bottom of the activity, past all of the other parts that we're going to do, on the last page, there are two boxes, and these show the different situations that you have for end behavior. So if n is odd, where n is the degree or the largest exponent, then I have two possible situations: odd degree and positive leading coefficient, odd degree and negative leading coefficient. The leading coefficient is the number in front of the x where the degree is. So my very first term, with the highest exponent, the number in front there is going to determine which way the ends point. So if it's odd degree and positive leading coefficient, it's going to rise on the right and fall to the left. If it's odd degree and negative coefficient, it's going to rise on the left and fall to the right. And I like to think of this as sort of an overall shape of a line. So there might be some curvy stuff in the middle, but we're focused on what's happening at the ends. So this is like a line with a positive slope from left to right, and this one is like a line with a negative slope from left to right. If we have an even degree, then if the leading coefficient is positive, it's going to rise on both sides. And if the leading coefficient is negative, it's going to fall on both sides. So this box represents that information. You might find it helpful as you're doing the MyLab problems. It's also represented in the second graphic. Both of these are pulled from the textbook, but this one you might find a little bit easier to look at. So whichever one works for you, then you can use that one.